everyone. We are back with another session with Dr. Anu Sidhu, who is a licensed and certified AP chemistry teacher. In the last session, Dr. Anu educated us about isotopes and also introduced periodic table. And today we are going to continue the discussion on the subject of chemical foundation, atoms, elements, and ions. Dr. Sidhu, how are you today?
Hello, I'm very much fine. Thank you, Komal.
Dr. Anu, in the last session, we discussed about isotopes. So I would like to ask, how do we represent isotopes of any element?
Okay, great. Great question. So I want to review a little bit about the isotopes. What are isotopes? So isotopes means these are the atoms of the same element which are having the same atomic number but different mass number. So in other words, what I mean to say is that they have the same atomic number, but they differ in the number of neutrons. So it is very important thing to focus that it is the like which fundamental particles basically they differ in the isotopes of any element. It is the number of neutrons which differ in the isotopes of any element. So that is the isotope, and we discuss about a few applications of the isotopes, right? Yeah. Now, how to represent an isotope? But before that, I want to introduce that how to represent any element. We know the symbol, but how to represent any element in chemistry, that is once you know about the atomic number and mass number. I think by this time, my viewers, they know about atomic number. That atomic number is the number of protons which are present inside the nucleus of an atom. And number of protons, they have to be equal to the number of electrons in a neutral atom because atom is neutral. And second term is very important, that is the mass number. Mass number means it is the sum total of protons and neutrons which are present inside the nucleus of an atom. Collectively, protons and neutrons are also called nucleons. So nucleons means the particles which are present inside the nucleus. Those are nucleons, and that is known as the mass number. In chemistry, atomic number is represented by Z, that is the alphabet, the letter, English letter Z, and mass number is denoted by uppercase letter A. So to represent any element, the rule is that we have to write the symbol of that element, and mass number is written as the superscript at the top, and the atomic number is written as a subscript at the bottom. Like for example, sodium. The symbol for sodium is Na. The mass number is 23. Atomic number is 11. So to represent a sodium atom, we will write 23 as a superscript and 11 as a subscript. So this is the way we represent the element. Now coming to the isotope. Like for example, hydrogen has 3 isotopes. That is protium, deuterium, and tritium. And what is atomic number for hydrogen? That is 1. So atomic number is 1. Protium, the mass number is 1. Deuterium, the mass number is 2. Tritium, the mass number is 3. So this is the way we will represent. You see that we have protium. This is the atomic number, which is as a subscript, and this is the mass number. Then this is deuterium. This is the atomic number, and this is the mass number. Then tritium, we have this is the atomic number, this is the mass number. So you see all these 3, these are the isotopes of element hydrogen. They have the same atomic number, 1, 1, and 1, but they differ in the mass number, 1, 2, and 3. So to calculate the number of neutrons in protium, you have to subtract the mass number A minus Z. So 1 minus 1, neutron is 0. Here A minus Z, number of neutrons is 2 minus 1. So that is 1. Here the number of neutrons is 3 minus 1. So that is 2. So you see how beautifully with this simple example, we can see that it is the number of neutrons which differ in the isotopes of any element.
That was quite interesting. Dr. Anu, in the last session as well, you introduced us to the periodic table. So, are we going to learn more about the periodic table today?
Yes, I am super excited to introduce more about the periodic table because I know this is the foundation. Once my students, they know how to read or understand the periodic table, they will enjoy learning chemistry more and more. So the last scientist, that was Mendeleev, which gave a broad view about the periodic table. He introduced the groups and the periods. Groups are, what are groups? That is the vertical columns, top to bottom, okay? And periods are the horizontal rows, that is left to right. So in modern form of periodic table, we have 18 groups, vertical column, and we have 7 periods, that is horizontal rows. One more thing is that this is the modern periodic law. It states that the physical and chemical properties of the elements are periodic function of the atomic number of the elements. So it means the elements are arranged in increasing order of the atomic number. But why? Why not mass number? Because atomic number is the fundamental property. All the properties of the elements, they depend upon the atomic number. Atomic number is the number of protons, and number of protons are equal to the number of electrons. And these are the electrons which participate in the chemical reactions. So everything is actually dependent upon that. So that is why the name of the scientist is Moseley. He introduced that. So it is the atomic number, increasing atomic number, the elements are arranged in the periodic table. Now, one way to memorize it, you start with the atomic number 1, like hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon. Argon is 18, right? Potassium 19, calcium 20, then scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc, gallium, germanium, and so on. Right? So we can just move on with the atomic numbers, right? Like I know it. I've memorized. The another easier way, what I suggest to my students is that always try to memorize the periodic table in the form of groups. Like group 1. Group 1 has hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium. Group 1 is called alkali metal. So that is a special name given to that group. Group 1 is alkali metal. Then group 2. Group 2 is beryllium, magnesium, calcium, strontium, barium, radium. That is the group 2, that is alkaline earth metal. After that, go to the group 13, which is on the right side of the periodic table. Group 13 is called boron family. No, that is boron, aluminum, gallium, indium, thallium. Then group 14 is carbon family. Carbon, silicon, germanium, tin, lead. Then group 15 is nitrogen family. Nitrogen, phosphorus, arsenic, antimony, bismuth. Then group 16 is oxygen family, which is also called chalcogens. Chalcogens means ore generating. All the ores are basically oxides or sulfide. So that is group 16. Oxygen, sulfur, selenium, tellurium, polonium. Then group 17. The special name given to group 17 is halogens. That is fluorine, chlorine, bromine, iodine, and astatine. Last but not the least, that is group 18. Group 18 is also called noble gases, and that is helium, neon, argon, krypton, xenon, radon. So this is group 1, group 2, group 13 to group 18. And in middle, we have 3 rows that is known as the transition metals. So I suggest my students to memorize the 3 rows of the transition metals from left to right, like transition series 1. That is scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. That is transition series 1. Then transition series 2. that is yttrium, zirconium, niobium, molybdenum, titanium, ruthenium, rhodium, then palladium, silver, and cadmium, like that. Okay. So this is the easiest way. And the last, we have the two rows at the bottom of the periodic table, and that is known as the inner transition metals. That is, one row is lanthanoids, and the bottommost row, that is known as the actinoids. So lanthanides and actinoids. So in the whole, what I can, as like, complete periodic table is, group 1 is alkali metals, group 2 is alkaline earth metal, and this group 1 and group 2, that is known as the S block. I will go into detail about the blocks also, but this is known as the S block of the element. And group 13 to group 18, that is known as the P block of the element. Group 13 to group 18, that is boron family, carbon family, nitrogen family, oxygen family, fluorine family, and noble gases. Then in middle, transition series 1, 2, 3, that is known as the D block elements. These are transition metals. And the bottom two rows, that is lanthanoids and actinoids, that is known as the F block elements. Those are called inner transition elements. So group 1, group 2, group 13 to group 18. These are called representative elements, S block and P block. And transition metals, that is D block elements, and inner transition metals, that is F block elements. So that is all about periodic table.
Maybe someday I will be able to learn all of these. All of these names they are on tips. So yes, maybe I hope so.
Yes, definitely. This is very easy. You start teaching, kids here and there, and you will memorize that. It won't come in just one day. Sometimes my students ask me, "How do you memorize all those?" I said, "Take it easy, take it easy. Don't worry about
It
that."
takes time. It takes time.
It takes time. Yeah.
So last but not the least, Dr. Anu, any questions for our viewers?
So yeah, I want my viewers to come up with some kind of rhythmic kind of model for the periodic table, where they want to give some kind of a suggestion how to memorize that, because I have plenty of those. I just want to know what they have in their minds about learning the groups and the periods, if they can have some kind of a model to learn about that. So that's what I want my viewers to do.
Let's see what the viewers come up with. Thank you so much, Dr. Anu, for sharing the valuable knowledge about the periodic table. It's very interesting as well. And I hope that our viewers are getting benefit from it as well. So that was all from our side. And I hope we all are getting benefit from our these sessions that we will be conducting in the future as well. Please like and subscribe to our SIDHU'S Academy on YouTube. This is Komal from Outlet Media signing off.